Now let's get started with our very first PharmCAT example. You can find most information about PharmCAT on the PharmCAT website at pharmcat.org. To download PharmCAT, the home page has a button that directly takes you to the PharmCAT GitHub repository or the download page of the latest PharmCAT release. Download both the VCF preprocessor and the PharmCAT jar file. On Mac, you can open the terminal to run PharmCAT. For the convenience of this tutorial, I've moved all of the downloaded file into a specific folder named PharmCAT tutorial. As you can probably already infer from the file suffix, this PharmCAT preprocessor is a compressed file that we need to decompress it to use whatever content that comes with it. Now this decompressed preprocessor folder have all of the Python script that we need to run the PharmCAT VCF preprocessor module. To run PharmCAT, you need at least Java 17, Python version 3.9.4, VCF Tools version 1.18, and HTSLib version 1.18. Check the versions of your software in your terminal. For HTSLib, we specifically need a tool named bgzip that comes with this HTSLib software. So just check to make sure that you have the right version of bgzip. As a Python script, the VCF preprocessor also requires certain dependencies. You can run this pip3 command to install all of the required dependencies for Python and for the VCF preprocessor. Since I have all of the packages installed, I will now repeat this step. Remember the input of PharmCAT is an VCF file. We can now go back to PharmCAT webpage and click the Example tab to download an example input VCF. Here, this PharmCAT positions.vcf is the example VCF that we have just downloaded from the PharmCAT webpage. You can run the following command to run the VCF preprocessor. Now this Python command calls the PharmCAT VCF preprocessor Python script under the preprocessor folder. The VCF parameter specifies the input VCF file for the VCF preprocessor. Now to normalize and standardize VCF files, we need human reference genome sequence. Here, if you don't specify a human reference genome sequence in your laptop, the VCF preprocessor would automatically download a reference FASTA file that we have prepared for you. But this would take a while, and this is also the only step in the whole PharmCAT that requires internet connection. Since I already have the reference human genome sequence in my system, I will interrupt the program and specify the reference human genome sequence for PharmCAT VCF preprocessor to speed up the example. Without specifying the output folder, the output preprocessed PharmCAT ready VCF will be stored under the same folder as the input VCF, but it will have a new suffix called preprocessed.vcf.bgzip to differentiate a preprocessed file from the input VCF. Also noteworthy, since this example VCF is a relatively simple VCF file, you won't notice much difference in the preprocessed and non-preprocessed VCF. But if you have an actual VCF file generated by a sequencing lab, different sequencing labs may have quite different variant representation formats for their genetic variants, given their own bioinformatics pipeline. In this example, we just carry on with this simple example VCF. Next step is to run the PharmCAT. Remember, besides the VCF preprocessor, all the rest of the PharmCAT modules, including the named allele matchers, the phenotyper, and the reporter module, are all written in Java language. So you just need to run this Java command to run all these modules in one step. For the input VCF to PharmCAT, remember to use the preprocessed VCF file. By running this command, you'll get the intermediate JSON files from the named allele metro module, the phenotype module, but as well as the reporter HTML result. Here, we just successfully run our first PharmCAT. Now, PharmCAT follows the semantic versioning. You can always find the latest PharmCAT release following the button on the PharmCAT homepage. Most of today's content is covered under Running PharmCAT and is specifically based on information from these 2 pages. Feel free to check them out if you're interested in learning more. This concludes the introductory overview of PharmCAT. More videos will be rolled out in near future. For example, topics on outside calls from other PGIS calling tools, multi-sample VCF files, and advanced functionalities in PharmCAT. Please stay tuned.